When a device on your network isn't under the administrative control of the network staff, it's called a rogue device. Rogue devices are often completely malicious. They exist for the sole purpose of stealing sensitive information like credit card numbers and passwords. It could be a rogue wireless access point, server, and so on. In our scenario, we have a rogue DHCP server on our network, and we're going to use Wireshark to detect it. As clients connect to the network, both the rogue and real DHCP server offer them IP addresses as well as the other network settings. If the information provided by the rogue DHCP differs from the information provided by the real one, clients accepting IP addresses from it may experience network access problems or have their network traffic sniffed as part of a man-in-the-middle attack. All right, I have Kali Linux open here, and I'm going to run Wireshark to see what's happening. I'll go to Applications, down to Sniffing, and over to Wireshark. Once Wireshark launches, I'll click on the shark fin to start sniffing traffic. It's running, so I'm going to jump over to the client machine and investigate why that client can't get to the internet. Okay, I'm on the client machine that belongs to the employee that can't connect to the internet. I have a command prompt here, and I'm going to do an ipconfig on the machine. Now, as I look up, I have an IP address of 10.10.10.11. The subnet mask is correct, but there's no default gateway. Also, my domain isn't corpnet.xyz. This one here says baddomain.com, so I seem to be having some problems. Just to double check, I'm going to do an ipconfig/release. Now let's do an ipconfig/renew. I'm getting the exact same information, so I'm going to investigate. Now I'm going to jump over to another workstation and see what IP addresses they're getting from the DHCP server. Okay, I'm on a different Windows 10 system. It's one that I use occasionally. I'm going to do an ipconfig, and I get some information. This domain, corpnet.xyz, is actually the correct domain. Down here, this IP ends with 195, which is in the range of my real DHCP server. When we checked the other machine, that one ended in .11. That's not in the right IP range for my DHCP server. Here, I have my default gateway. The information down here is from another demo I did. It's not relevant here. So I'm going to go turn off my real DHCP for a few minutes, come back here, and renew the IP address to see if I pick up something from the rogue DHCP that appears to be running on this network. Okay, I went in and turned off the DHCP server. I'm going to do an ipconfig release, and I get a message saying I need elevated privileges too. Let's close this and reopen the command prompt with elevated privileges. I'll say yes to the user account control. Okay, let's try that again. That's ipconfig/release, and then I'll do ipconfig/renew. Now I'll just do an ipconfig, and when I do, we get baddomain.com. This IP certainly isn't coming from my DHCP server. It's not even in the IP range that I've set up. That tells me I have a rogue DHCP server. I'm going to turn on my real DHCP server again so I don't forget. All right, let's turn the DHCP back on. I'm going to try to obtain a new IP address again. I'll do ipconfig/release and then ipconfig/renew. Now it looks like my real DHCP server beat the rogue DHCP server. This gateway and IP info is from the correct DHCP server, but I still need to find out more about this rogue DHCP server. At this point, we're going to go back to Wireshark on the Kali Linux system and see what's going on there. I'm back on the Kali Linux machine where Wireshark has been running the entire time. First, let's stop sniffing. I want to filter the traffic and just see the DHCP events. We can filter things in Wireshark, so if I type in DHCP, the filter area turns into a salmon color. That means that this filter isn't correct. I want to type in boot P, the filter for DHCP traffic. When I do, I get the filter to work. Here's something I know. My DHCP server's IP is 10.10.10.1. That's what I should be seeing here. Instead, I'm getting a DHCP offer from 10.10.10.10, which is not my DHCP server. If I scroll down there a bit, I can see 10.10.10.197 getting a request for an IP from the real DHCP server, 10.10.10.1. If I scroll down more, I can see a mixture of traffic from the rogue DHCP and the real DHCP. So somewhere on this network, I have a rogue DHCP server with the IP of 10.10.10.10. Now, come down here and I can see the MAC address for that device. It says it's the source MAC address. To fix this on a temporary basis, I can just kick that device off the network based on the MAC address. Long term, I need to prevent this from happening in the first place. Rogue DHCP servers can be stopped by an IDS with appropriate signatures, as well as by certain multi-layer switches configured to drop the packets. One method for dealing with rogue DHCP servers is DHCP snooping. DHCP snooping drops DHCP messages that aren't trusted from a DHCP server. You can configure DHCP snooping on LAN switches to prevent rogue DHCP servers from operating. That's it for this demo. In this demo, we investigated a rogue device on the network. First, we identified an IP address that was assigned by the rogue device. Then, we verified that there was a rogue device from a second system. After that, we viewed our filtered Wireshark traffic and identified the rogue DHCP server's IP and MAC addresses.